Well, last time we were talking about solving equations of exponential functions. And today we're going to continue on that. We left off at number 5, right? We left off at number 5, exp1a. And we understand these are if statement, and we had 4 ways to solve it. And when we understand these 4 different methods of solving these exponential equations, when you actually solve it, you're going to just use one of them. Just use one of the methods, okay? But it's good to it's good to know how to use these methods and how and when we can use this. Hello, surprise, surprise. Now this morning when I re-log in my laptop, I found that I can, the video works now. Okay, so you get to see my haircut. But the haircut is a little bit old. It's been a few weeks past. But anyway, welcome back. I'm happy to see you guys. All right. Any questions? Andy, Mikkel, do you have any questions? No questions, not yet. Okay, if you have questions, please don't hesitate. Okay, so we're gonna start out from, well, we did number 5 yesterday. Okay, so this is what we did for number 5. Would you like to try number 6? Would you like to try number 6 just to get started? Number 6 goes like this. We have 3 to the power of 4x plus 1 equals to 2. I think I just get started. You guys do it with me. How about that? Okay. Well, in this case, of course, we can still do 4 different ways to do it, right? And you can go by definition. We can go by definition, and we can go by any way you want, really, any way you want. But if you do not go by definition, what would you do? You have 3 other ways to do it, right? We have 3 other ways to do it. So let's go by definition. Okay, so we have 4x plus 1 equals to log base 2, log base 3 of 2. Right? By definition. By definition. And then we just subtract 1 on both sides. Minus 1. And divide both sides by 4. Or multiply both sides by 1/4. Okay, multiply both sides by 1/4. So let me show you how I would prefer this being written. Okay, multiply both sides by 1/4. Okay. Even though sometimes I just want to mention this way of writing it, and I have shown you this way of writing it, I think at the trigonometry. And if you write it this way, of course it's not wrong. It's not wrong, but this this way and the other way are the same. They're the same. They're the same, but this way is actually preferred in a lot of situation. In a lot of situations, for example, the lighter way is more like somebody has a very big head and a very small body. Okay, but this form seemed to me a little bit more balanced. A little bit more balanced. Okay, so I'm going to show you this way of writing it, and which I feel, is a little personal favorite. It's a little personal favorite. But if you know the difference, right, then you would use it flexibly. You'll use it flexibly, especially I would say there's a moment in calculus 2. Okay, sometimes you like to write it this way. Okay, you like to write it this way. But anyway, without further ado, I do want to show you another way to do this though. Okay, which is to take a logarithm on both sides. Okay, which is take log, is one of the 4 methods we talk about. Okay, when we take a logarithm on both sides, okay, first you need to check whether both sides are positive. Okay, because that's determined by, so this is one of the 4 methods, right? You take logarithm on both sides, right? So let me copy and paste this part, right? When we copy and paste this on both sides, I'm sorry, when we take logarithm on both sides, we need to be aware of domain. And because we have all these different choices of base, we can choose base of anything. As long as that base is larger than 0, not equals to 1, we're good. And we also have the temptation of choosing, say, base 3, right? We can choose base 3. However, if you consider the fact, okay, at the end of the question, excuse me, at the end of the question, you might have to use a calculator. A calculator only has common log, and sometimes common log and the natural log. Then you would probably like to take a common log or natural log. Now, then another consideration would be, well, most of our calculator has natural log, and natural log is sometimes the preferred form. Okay, so in this circumstances, I'm going to take a natural log on both sides. Okay, I'm going to take a natural log on both sides. Remember, I want you guys to use natural log as much as possible, right? Because you only be using natural log probably exclusively by the time you're in calculus. The narrative here is, if this is true, then this is true. Okay, so we take natural logarithm on both sides. Okay, and then by power rule, we have 4x plus 1, natural log 3, each equals to natural log 2. I just made a mistake. I applied the power rule on both sides, and I apply the power rule on the left-hand side. If I write it like this, I have made a mistake. Can anybody tell me what mistake did I make? What mistake did I make? Yeah. I missed the parentheses. I must have this parentheses. Okay, this parentheses is absolutely necessary. Okay, this parentheses is absolutely necessary. You can do common log, which is going to be the same thing, very similar, very similar. Okay, so I'm going to continue on the natural log. And now x is the the variable we want to isolate. We want to isolate. There are a number of different things, different ways to do this. Okay. But before we do it, you must treat ln's natural log 3 and natural log 2 as a single number. Okay, so treat, okay. This is something you may not quite used to. Treat ln 2 as a single number. And likewise, treat ln 3 as a single number as well. What does that mean? That means you should not separate them. Okay, treat ln 2, ln 3 as a single number. So don't separate them. Don't write ln alone. Okay, don't write ln alone. Never. Okay, you never write ln alone. You never write a logarithm of anything alone, because you have to indicate the input. You have to indicate the input. That the rule of the function applies to what? Just like sine x, right? You never write sine without attach an input. Okay, you never do that. And in this case, we treat ln 2 and ln 3 alone. With that, one of the ways to simplify this would be you distribute ln 3 to 4x, okay? But I'm not going to go that way first. I will go that way afterwards, okay? I'm preparing you for harder questions that later in the section. Okay, I'm preparing for harder questions. So what I'm going to do here is that I'm going to take ln 3, I'm going to multiply 4x, and I take ln 3 multiplied by 1. Okay, so I have 4x okay, multiply ln 3 plus ln 3 equals to ln 2. You guys see the distribution? Now, why don't I put the x behind ln 3? Do you guys follow me? There's a lot of interesting details I wish to address with you before we touch those harder questions, Okay, so let me make a little bit adjustment to the window. Okay. So I'm going to put this on the, okay. Be careful. I'm going to put a little note here. Okay. 4x ln 3. Okay. Keep it this way. Don't write 4x times ln 3 as 4 times ln 3x. 4 times ln 3x. Follow me? Because normally we will be writing, we write the variables at the end, right? We write the variable at the end. But here you don't. Why? Because when you write it this way, it can be confused that we taken ln 3 for 3x. You follow me? We're taking natural log only on the 3, not on the x. But if you write it this way, it's going to be confusing. Okay, so don't write it this way, because if you write it this way, most of your teachers and will read it as mistake. Okay, don't write it that way. And the other thing is, however, right? If you really want to write it that way, okay, if you really write it this way, right? You can write it this way. That would be okay. Okay, so this expression is the same as that, but you can do this, but it's okay to do this. Or you can do ln 3, just put a parentheses. Okay, so now we ask you not to do this, right? So you have 3 options. You have 2 options. You can do this form, this form. Which of the form you think is simpler? Or even the other form, or even 4 times ln 3 parentheses x. All 3 forms is okay. Which one do you like? Which one do you think is simpler?
First one.
Could you say louder?
The first one.
I agree. I totally agree. When a parentheses is not necessary, just don't use it. You will find this a very, very helpful convention. Okay, you don't want to have excessive parentheses, even though in this case it's not excessive, right? Just 1 parentheses. In the future, when you start writing code, right? When you, I think most of you, if you're in STEM major, one day or one day in the near future, you will start writing programs. In your writing programs, whatever code you write, you're gonna be using parentheses. Okay, you don't want to have too many layers of parentheses. Even the debugger doesn't check properly for the parentheses. In most of the cases, you have to check the parentheses and make sure they're paired properly. Okay, so learn to use parentheses only when it's necessary. It's very important, even when as you're taking math classes, okay? Remember, math is the foundation of computer science, computer programming. But anyway, without further ado, so we can see that this form is preferred. This form is preferred. You just have to learn to read it, that the constant, okay? The constant is 4 times ln 3, and the variable is in the middle. Do you follow me? Okay, and the variable is to be isolated. All right, so I inserted a little bit of these conversation, so don't do that, don't do that, okay? So without further ado, next, I'm gonna write, I'm still gonna write 4x ln 3 equals to ln 2 minus ln 3. We subtracted ln 2, subtracted natural log 3 on both sides. Okay, so one number subtracting another number. So now we're gonna divide by 4 times natural log 3. Okay, so we're gonna divide both sides, okay, by 4 times natural log 3. 4 times natural log 3. Okay. 4 and 4 reduced. Natural log 3 and natural log 3 reduced. So in the end, we get x equals to the right-hand side. Okay. May I ask you guys to take your time to reproduce the steps, Okay, and then I'm going to show you another way. Okay, I want to show you some of the algebraic flexibilities which you will need. Okay, so I'm going to stop the share for 2 minutes. Do you think 2 minutes is enough? Okay, so I'm going to stop the share for 2 minutes, and you guys going to reproduce it. Go for it. Okay, Cortland has a very good question. He said, how about, would you just leave the answer as that? Or, okay, I'm copying Cortland's answer, okay? He wrote ln2 minus ln3 divided by 4 times ln3. If you write it this way, Cortland, you must have a parentheses, okay? You must have a parentheses. If you write it this way, you must insert parentheses for the numerator. If the parentheses are missing, they will be wrong. You guys see the comments? Done? All right, let's come back. Okay, you see, it's not too difficult, right? But there are some new things you need to get used to, right? Which is the numbers are separated. Okay, and as the question asked by Cortland, that if this parentheses is missing, that will be a mistake. Why? By order of operation. And this will be calculated first. Okay. And it's a big mistake. It's a very big mistake. Okay. And not only you need a parentheses here, you also need a parentheses here. Why? Let's practice. Let's see what happens. Okay. With a calculator, it's very easy. Suppose I don't have parentheses here, and I don't have parentheses here. Okay, and I'm having this expression. Let's check. It's the easiest way to do is just check the numerical value. Check the numerical value. They're different. You see, they're very different. Do you guys see that? Okay. And now if I put a parentheses here, guess what? We're gonna get a different number too. Do you guys see that? Different number, right? Now, only when we put this number, this parentheses in place and this parentheses in place, now the first number and the last number should be the same. Do you follow me? Do you follow me? So my answer to Corlan's question was still a little flawed. Okay, so let me go back there. My answer to Corlan's answer need a modification. Okay, so we also need parentheses. Okay, so let's make it complete. You also need parentheses for 4 times ln3. Okay, I'm going to explain to you. Why? What what's happened? By order of operation, when you ideally in the ideal world, right? Actually, in programming, you're not going to be using this. It doesn't accept this in your code. In most of the program I know. Okay. So, but when you write it this way, what's being done? Okay, so order of operation. Okay, on the first one. The first one is done is ln3. Maybe I should make a table for this, right? I should make a table for this. That will make it easier to okay, so let me do a table. 1, 2, 3, 4. So I need 4 rows, 4 columns, sorry. 4 columns. Order of operation. On this one, okay, on this one, okay, on this guy, and on the last guy. Okay, the easiest way for us to check, if we know the numerical values are different, that already tell us something, the numerical values. That's the easiest thing to check. That's the easiest thing to check. And we also have seen that the first one and the last one are the same. Right? The first one and the last one are the same. So I mean, let me put this, give me the numerical value. Hold on. Give me the numerical value, right? Give me the numerical value. Wow. Software can be temperamental sometimes, right? So these are the numerical values we get. To understand this, okay, very important, okay? It's important not only for this class, it's for your future classes, for your future coding and all of that stuff. All right, the order of operation here, the first one is done, is of course ln2. ln2 is done. ln3 done separately. Okay, and then number 2, I want to keep it a little smaller, okay, separately. And at the same time, you can even do 4 times ln3, okay? Then ln3 is, well, ln3 is done. Oh, well, we don't need to. 4 times ln3. Oh, sorry. 4 times ln3. 4 times ln3, okay? 4 times ln3. Because we got ln3 already, right? So we do 4 times ln3 and ln2. Oh, gee, sorry. Okay. And then ln2 minus ln3 separately. Okay, do you follow me? These orders is not absolute. These orders is not absolute. Okay, so let me insert a few more rows. Okay, so basically you do ln2 minus ln3. Okay, ln2 done, ln3 done, subtraction. And take the ln3 we did and multiply by 4. So all of these done unit are done separately in whichever order. Okay, so maybe I don't put 2 here. Okay, I don't put 2 here. Okay, so what I meant is that 4 times ln3, ln2, ln3 is done. They can be done in any order. Okay, and next, second step number 2 is that we do the division. Divide. Okay, so divide will take what has been done in step 1, and we take what's been done in 4 times ln3. Do you follow me? All right. With that, and that's you get the final answer. Okay, so to show you how the number is done, right? To show you how the number is done, because you will be asking the question, so if I don't have a calculator, how do I know these are different, right? So what I'm trying to tell you, you have to understand the order of operation. That's what helps me to decide where do I put parentheses. Order of operation. Please excuse my dear Aunt Sally. Okay, so from order of operation, excuse me, I can decide. So you can decide too. Okay, you don't need me to be with you all the time. Okay, the key is order of operation. For example, so in the actual steps, right? In the actual steps, I'm going to show you that in this case, we're going to get ln2. Hold on. Okay, so I'm going to show it's ln2. Give me a numerical value, right? ln3 gives me a numerical value. It gives me numerical value, right? And then you see the order of operation. We're going to take ln2 minus ln3, right? And that is to take this number, subtracting this number. Okay, so I have done the numerator. And next, I'm going to do 4 times ln3. 4 times ln3. 4 times ln3 is 4 times ln3 is this guy. And last but not least, now I'm putting these together. Okay, so this is pretty much the steps you will do. So you take this number from ln2 minus ln3. Okay, and you take this number, of course, this 4 times that is 4.3944. You put it over here, then you divide. Do you follow me? So this is number 1. This is number 1. Okay, this is number one. So now look at number two. How number two is done. Okay, let's how number two is done. It's not going to be done the way you wished. It's not going to be done the way you wished. Okay, so this is how it's been done. Now, first of all, you see there's an ln 3/4. Okay. So the calculator would think, okay, this is one confusing point. Okay. So ln 3/4, or is it ln 3 divided by 4? That's one confusion. And let's see how the calculator read it. Okay, because I don't even know. I don't know. Okay, trust me, I don't know at this point. Oh, sorry, what's going on here? Oh gosh, hold on. So at this point, I need to figure out, because I don't know. I don't know the order of operation. Okay. So we're gonna investigate this. Okay, so how does the calculator read it? Because what do we wished for? So for ln 2 minus ln 3, and that's not going to be done at all. So what, by order of operation, what will be done is this part first. And this whole piece subtract from ln 2. You follow me? Okay. But when we come to this point, so what we're going to investigate is it going to be doing ln 3/4, or is it going to be, so we're going to investigate, okay? So now, okay, so if I put this together, I still don't know how it's been done, okay? So I'm going to investigate. So I'm going to say, okay, is it ln 3/4, right? Or is it ln 3 divided by 4? You understand my question? Do you understand my question? Very different. Do you see? Very different. Now the final, but I still don't know how this calculator, if you guys have a calculator, so please feel free to take it out. Okay, your cell phone should have a calculator, right? This is a big thing. Okay, not actually these calculations is not important to this class. It's but it's important to what? To your future programming. Okay, so that's why I want you guys to understand, you need to know how to determine the parentheses from mathematical perspective. Don't wait until this moment, you have to figure out. Okay, don't wait until this moment. This is messy. This is very, very messy. Okay. So now I'm trying to figure this out, how this is done, because ln 3, so this is the number. So now if I put these number in, all of these together, I get this number. So if this is being regarded as 0. So if this is the case, it's being regarded, right? And multiply ln 3, I know this order to see if we get the same number. It doesn't. You see, it doesn't. But if I take this number, multiply ln 3, let's see what do we get. Huh. There you go. Now I find out. I have found out. I found out. Are you guys with me? Are you guys with me? Okay. So in this expression, if you write it this way, it's not going to do the way you want it. What's going to be done is that the programming is going to do ln 3 quarter first. They're going to do ln 3 over 4. They're not going to do ln 3 divided by 4 times ln 3. Okay, so that's why we get that wrong number. Yes, that's why we get that wrong number. This kind of phenomena happens not only in this class, even in this class, actually, we don't do much of this. Okay, we do a lot of theories and we do a lot of, concept related thing. We don't dive into the calculation as much. Okay, at least I don't want to deal with it. I personally don't want to deal with that. But I need to teach you guys how to parse with parentheses, which is essential for your future programming. Okay, so when you write it like this, it's not going to be regarded as ln 3 divided by 4 times ln 3. That's totally not what we wanted. It's actually being treated as actually being done the way, okay, they first do 3 divided by 4, 0.75, and then they do the ln 0.75, and then multiply ln 3. You see what I mean? So this is totally a mistake on a very big scale. If you are doing scientific, if you're doing any kind of numerical computing, this isn't going to give you a disaster. This is the kind of calculation will give you disaster. I'm not talking about ordinary disaster. It could be between a rocket ship go up to the space as planned versus the rocket ship is going to explode. That's how big that magnitude can be. Do you follow me? I'm not exaggerating. Do you guys see the Challenger explosion? Do you guys know Challenger explosion? Maybe you're not old enough. If you look up a Challenger explosion, it was actually caused by a bug in the program that failed to convert either metric system to customary system or vice versa. I don't remember exact the detail. It was a programming error. Caused us to have lost 6 lives. Okay, 6 lives. If you go down the beach, in Hermosa Beach, there's a memorial. There's a memorial for one of the astronauts. I forgot his name. Okay, so this is not a small matter. This is not a small matter. So you can see that please don't do this. So what do we need to do is that you need to insert parentheses here. Okay, but if I insert parentheses without insert parentheses here, it's also going to cause problems, right? So the proper way for doing this, if you want to write the way that Cortland suggested, you have to put parentheses on the top and put parentheses in the bottom. Okay. Last but not least, I'm going to insert. So you guys understand, right? This is very, very serious issue. Very, very serious issue. Okay, this is very, very serious issue. One more thing. So suppose I do this, right? Suppose I'm going to insert one more column, right? So instead, I have the parentheses on the numerator, but I don't have the parentheses for the denominator. What will happen? This calculation will not be the same as well. I want to show you here. It's not going to be it's not the same as this number. Do you guys see that? Why? Because what happens is that This part will be done properly. It will be divided by 4 times ln 3, but instead by order of operation, this number will be divided by 4 and then multiply by ln 3. That's what happened. Do you follow me? So now, in summary, okay, don't do this. Don't do that. That's not enough. This is okay, but not this one. All right? And the correct ones are this one and this one. Do you follow me? Very important, very, very important. Okay, so we're gonna put this behind us. We're gonna put this behind us. So you know that how to parse when you convert the mathematical expression. I would say the rule, let me give you the rule of thumb. Let me give you the rule of thumb, okay? I'm gonna remove these annotation. Okay, you may say, oh, this is very confusing. Yes, it can be very confusing. And when you write programming, right? Suppose you're given this thing, then you write it this way. Your program will not detect it as a mistake. Trust me, okay? All the programs I know, of course, I'm a little behind on some of the new programmings, right? But all the program I know of, I would not be surprised. They're still the same case. If you intended to calculate this guy, but you input this one, it's not going to detect it's a mistake. You have to go in there to write more code to check the steps and check your own calculators, make sure those are done properly by calculation. This one, the program or debugger will not give you as a mistake, and this will not give you as a mistake either. This will not give you as this one will not give you as a mistake. That's the problem. That's so hard because debugger only can check the syntax error, and you have no syntax error here. No syntax error, no problem. Okay. So now, what's the rule of thumb? You probably have figured out the rule of thumb already, right? So what is the rule of thumb? Tell me, what do you think is the rule of thumb? What do you think is the rule of thumb? From what do we just talk about? Because you want to say, hey, Ms. Wang, I want to know in the event of having this situation, it's, I don't want to make those mistakes, right? The rule of thumb is this. You take the entirety of the numerator, you put them in parentheses. You take the entirety of the denominator, you put them in parentheses, and then you put the slash. Okay? This is the general rule of thumb. So these two already tell you that's the rule of thumb. And this is the same as if you take a statistics class. Well, when I was teaching statistics class, right, there's this formula to calculate standard deviation. And there's a similar mistake. Okay, when the student punch in the number in calculator, in that class, we have to do numerical calculation. Oh boy, they get different numbers. They don't get the right number. They don't understand why I don't get the right number. Well, because order of operation. And when you use a calculator, it's only right horizontally. It doesn't do this form. Right? So when you do math, you do this form. When you don't do math, you have to do this form. How to convert? right? How to convert. All right, so without further ado, I think that's enough, right? That's enough. But very important, very important. So you guys can reproduce it, right? Okay. We talk about lots of details. Let's keep going. Let's keep going. And next, to further warm you up, I want you guys to pick 2 questions from number 7 through number 10. Pick 2 questions, number 7 through number 10. Pick 2 questions to work on. Your turn. Okay, and I want to see your work. I want to see your work. So please upload. Pronto. Are you guys are gonna get a quiz today, huh? You guys are gonna get a quiz today. To pick 2 questions to work on. Okay, just hold on a second. I'm gonna just grab, I'm gonna refill my teacup. I'll be right back. Good to see you, Mikkel. Good to see you, Bailey. All right. I'm ready to see your submission. Great, great. All right, so let's get to see the, let me grab the, oh, I need to log in. My cell phone get it first. I'm gonna log in the, huh. Let me do this. Come on. Okay, welcome. Welcome to submissions. Please do submit your work. So here, I can start looking from. All right, let's see. This is the work done by Bailey. You guys see that? Yes? All right, so I'm going to grade it 9 to the power x. So what he did, he took logarithm on base 3 on both sides. That's perfect. And common, power rule. So x is down. So log base 3. So 2 times x equals to 3. So 2x equals 3, x equals 3 half. Perfect. Okay, that's number 8. Any more submissions? Perfect. Perfect job. Okay, every step is correct. Okay, every step is correct. Next person, next submission. Okay, very good job, Bailey. Anybody else would like to submit? You see number 9 and number 10? There's a natural log there. I wish to see someone do natural log. Number 9, number 10. Okay, if there's no submissions, I'm going to do one for you, okay? So we're solving e raised to the power of 5x plus 4, okay? 5x plus 4 equals to 3, okay? We can take logarithm on both sides. In particular, we can take a natural log on both sides because both sides are positive, right? So we have ln. Okay, so we're going to take ln on both sides, natural log on both sides, natural log on both sides. Okay, natural log on both sides. And then what do we get? We get 5x plus 4 times ln e. What does ln e equal to? What does ln e equal to?
1.
That's right, 1. Okay, it's equals to 1. So we can drop it, right? We can drop it. There. You guys follow me? when you read the textbook about these questions, it's not going to show you those parentheses, ln e and stuff. They're going to go straight here. You're going to go straight there. Okay. And then we're going to subtract 4 on both sides. Okay, and then divide both sides by 5. Okay, divide both sides by 5. 1 over 5. Okay, ln 3 minus 4. That's it. In this kind of questions, it seemed to be the most natural thing to do is take a natural log on both sides. Okay, you'll be doing this, in calculus 1, one natural logarithm is involved, or exponentials are involved. Okay, so we're gradually preparing ourselves for the harder questions that is coming ahead. Okay, and look at the next group from 11 to 14. Okay, let's look at from 11 to 14. Look at this group. Look at this group. From 11 to 14, what do you see? Take number 11, for example. What would you say?
No solution because 0 can't be in the domain.
That's right. Perfect. You want to be aware of the domain, even when you're solving equations, even you're dealing with the if statement, because whatever if of something, that can only be happening in the domain. If outside the domain is not, or outside the range, is never going to happen. Okay, it's never going to happen. Okay, so when you see that, okay, and you say there's no solution. What does it mean, no solution? No solution means that if you want the output to be 0 for that function, it's never going to happen. There's no input to make that output, no solution. And you can even attach a reason because what? 3 to the power of x is larger than 0. You see the range, right? Telling us it's impossible for any real number x. Okay, I wish you to recall the narratives we have for domain and range, Okay, for domain and range. Okay. So about number 12, 13, 14, same. None of them have solutions and the reasons are the same. Okay, that respective functions range does not include the number on the right-hand side. Okay, so let's move forward. 15. Okay, this time we're going to look at the group from 15. Let's do it as 3 groups. We look at 15 and 16. Okay, I'm going to do 15. You're going to do 16. How about that? Okay, we're gradually preparing you for the last 2 questions, which are the hardest. Okay, so number 15, we have 2 to the power of 1 minus x equals to 3. Okay, so I'm going to put it on the top. Let's do it. Just make it easier to track. Okay, now you can take logarithm on both sides. Can we? Or we can use definition. If I use definition, I do 1 minus x will be equals to log base 2 of 3. Okay, and then what I do? I will add x on both sides. Subtract the log base 2, 3. Okay, so x equals to 1 minus log base 2 of 3. You certainly don't have to do the same way as I did. I just want to give you a little different picture that what other people might be doing. Okay. Let me guess. Most of you probably are more used to doing this. Okay, most of you probably more used to do this. Subtract 1 on both sides, right? Right, subtract 1 on both sides, you have subtract 1, right? And then you're going to multiply by -1 on both sides. So x equals to, this guy. You still get the same answer. You still get the same answer, of course, right? But what I did here is that I just simply adding x on both sides. Okay. Have some flexibilities in algebra. Okay, so what I would do is I'm adding x on both sides and subtract this guy. Okay, and on my next step, I will have x, right? And over here equals to, and then I'm subtracting this guy on both sides. Yeah, you guys see that? And then I just switch the side. Okay. Doing algebra, you want to be flexible, and you want to be precise, and you want to be quick. Essential for your success. Okay. By the time you're in calculus class, you're not going to allow you 5 minutes to do this. Too long. Too long. Okay. But whichever way you do it, we can all pass those. We can pass all of those. We're done. So now your turn. 16. And these kind of flexibilities, maybe sometimes you skip a step or two. That's all fine. That's all fine. By the time you're in calculus, a lot of those algebraic steps may be skipped. Because you've done so much exercise. You can, okay? Just like a skilled chess player, they can, he can look maybe 3 steps ahead. Okay, another chess player can look 10 steps ahead. I don't know. I'm not that skilled chess player, right? Okay. Your turn, number 16. If you want to share your work with us, and I'll be happy to see and comment. I heard something. I heard something. Look at that, Mikhail, your avatar is so cool. I love it. Is that you, Mikhail? Is that you, Mikhail? I think that's you. Did you guys see that avatar? You share. I think we need to download this. It's a little bit, I want to make it larger. Okay, I want to make it larger. Thank you for sharing, Mikhail. Let's look at this picture. Okay, number 16. Number 16. All right. So he copied the question correctly. And he took a natural log on both sides. You get 1 minus 4x equals to ln 2. Perfect. Perfect. And he subtracted 1 on both sides and divide both sides by 4. Okay. If you divide both sides by 4, and then okay, so I'm gonna, all right, so what is this? Do you mean, Mikhail, do you mean this is x equals to that? Mikhail. Okay, so it seems what he did, he divided by 4, so that the left-hand side would still be a negative x. Okay, so let me just insert what he has on the left-hand side. He has a negative x equals to, and this thing, right? He has a negative x equals to this guy. So this will be negative x equals 2. Okay, so that's after he divided by 4. And then he did some switching. So that become x equals to 1/4 1 minus ln 2. I agree with this answer. Do you? But I don't agree with that one. I don't agree with that one. Do you guys follow me? Yes. What he did is that he basically applied the negative sign. I know he did a lot of things in his head, okay, which is great, okay. But just make sure that when I'm reading your work, I'm filling those gaps. That's okay. You know, I can fill in those gaps if you skip a step. That's not a problem, okay. But when you have x here, you're gonna have 1/4, right? 1/4, and he switched this ln 2 minus 1 to 1 minus ln 2. That's what the negative sign is absorbed, okay? And the next one is he multiplied quarter with 1, and then he needs to also multiply the quarter with ln 2, but he missed that. So what's missing is something is missing here. You see that, Mikhail? You see that, Mikhail? Okay, so you need to have a quarter in front of ln 2. All right, otherwise it's a good job. I can see you got the hang of it. Thank you for sharing. Okay, so I'm going to give you the final correction. Okay, so basically you will have ln, you take ln on both sides, right? So this is ln 2, sorry. And then the next step, you have 1 minus 4x equals to ln 2. That's a one number, don't separate, right? And then in the end, we get x equals to what? Quarter of however you get there, 1 minus ln 2. Okay, so I skipped some steps here. Is that any issues? Are there any issues here? No? Okay. But if you want to rewrite this, okay, in expanded form, you will write it as 1/4 subtracting 1/4 ln 2. Okay, so this 1/4 is what was missing in the work we just demonstrated, we just showed. Okay, so we need that 1/4. Now, if you are to write this as, suppose in your program, what would you do? Can you write it this way? Or suppose, let me write a mathematical form, right? 1 minus ln 2 divided by 4. Would this be the same as 1 minus ln 2 divided by 4? That's right, very good. What's needed is that by the rule of thumb, you need parentheses. You need parentheses. But in this case, the number in the denominator is a single number, is number 4. So you don't need to worry. So you can just put one parentheses. Okay, so if you write horizontally in your program, that's how you write. Okay, so that's number 16. Very good job. Very, very good job. So let's look at 17 and 18. Okay, if I do 17, you will realize 18 is a piece of cake. Okay. Even though both sides are positive, you don't want to take a logarithm yet. You don't want to take both sides logarithm yet. Okay. You want to combine some terms. For example, I have an 8 here on left hand side. I have a 20 on the other side. So I'm going to subtract 8 on both sides. Okay. So I'm going to subtract 8. I get 12. This is the moment. And after this step, you take logarithm. Okay. It's the same for 18. And by the time you see this, it's similar to what we did, right? It's similar to what we did. So can you finish this? Can you finish 17? Right, the point we're making here is when we take logarithm on both sides, just remember, okay, definition, because there's the root cause that we take logarithm on both sides, and we want them to be simple enough. In other words, you just have one term on left and one term on right, and that's when you take logarithm. But if they're in addition, and you cannot apply any rules of logarithm, and then you don't take logarithm here. So don't take logarithm here, even though both sides are positive. Okay, don't take, even though you can, but you're not going to go very far. Okay, don't take logarithm. Don't take ln on both sides. Don't take ln on both sides yet. Okay, even though both sides are positive, don't just take them blindly. Okay. So take it, now you can take it. Now we can take it. Did you finish? All right, so we have some time left, so we're going to attack the two hardest questions next. Okay, so I'm going to do for 1 minus 4x and equals ln 12. And I'm just going to quickly wrap this up. Okay, so x equals to quarter 1 minus ln 12. Do you agree? Do we get the same? Okay, so now we are going to attack the last two questions. 19. This is probably the hardest question of all. 20 is actually not as hard. Okay, 20 is not as hard as 19. So I'm going straight to the hardest question here. And 2 to the power of 3x plus 1 equals to 3 to the power of x minus 2. Okay, tomorrow we're going to revisit. Okay, we're going to revisit. So try it. Both sides are positive. That's not a problem. If we use definition, it's going to be messy. Okay, we have 4 methods, right? If we use definition, it's going to be messy. Even though we can do the graph, right, it's still difficult to identify the answer. All 4 methods considered, we're going to end up taking logarithm on both sides, right? So the question is, do you take log base 2 on both sides? Do you take the log base 3 on both sides? Because when you take a logarithm, you have to take it with the same base, right? You have to take it with the same base. So either one is a good answer. Either one is not a good answer. So we're going to end up taking a logarithm, which is commonly available on the calculator. And in particular, I'm going to take my preferred one is, you know, my preferred one, right? It's natural log. Okay, I encourage you guys to try any other way, okay? Any other way you want. It's okay. Okay, I will have questions on the quiz to inspire you to experiment some more, okay? Because all of these practice will improve your algebraic skill. Your algebraic skills, that's the goal, okay? All right, so with that being done, we're gonna have power rule, 3x plus 1 of ln 2 equals to x minus 2. You see, I'm being very careful. Okay, I'm being very careful. There's x here and there's x there. You have to bring them together. We have to bring them together, right? We have to bring them together. Remember, we mentioned earlier, you want to treat ln 2 as a single number, ln 3 as a single number. Don't separate them. You cannot separate them. Okay, and we need parentheses. All right. The next step is that we're gonna be on the journey to bring the terms with x with the variable together and bring the terms without the variable together, and they're separate on one side. Okay, so looking ahead, right? What do we want to do? We want to get to something multiply x equals to something else, right? That's what we want to get to. And then we can divide both sides by the star, right? Now, to get there, we're going to distribute the ln 2 inside. So we're going to get 3 times x ln 2. We have seen something similar, right? We've seen something similar. Plus ln 2. Right, so we distribute ln 2 with 3x, and we distribute ln 2 to 1. So we have 3x times ln 2 One contain x and the other one does not. The other side. ln3 is distributed to x, so we have x times ln3 minus 2 times ln3. Okay. Now, these two terms contains x, and these two terms do not. So we're going to separate them. So 3x times ln2 is going to be subtracting x times ln3, and negative 2 times ln3 subtracting ln2. You guys follow me? So what have we done? We subtracted that term on both sides. Okay, and we also subtracted ln2 on both sides. Do you follow me? A lot of you like to show these pieces of work. As a matter of fact, as you move on to your, your next math classes, I will highly recommend don't show. Don't show. Okay, don't show. Do it on your scratch paper. Don't show. Okay, just go straight here. From this line, go to the next line. All right? Don't show. Well, if you cannot help it, that's fine. If you cannot help it, but in the standard text, you never see things like this. You never see like this. You never see anything like this. Okay? So without further ado, so now we get to this place, and we're going to factor. We're going to factor out the x. Okay, so we're going to factor out the x. The x is out, and we have 3 times ln2 minus ln3 equals to the right-hand side is that. Okay. Did we get there? Did we get to this place that we intended? We did, right? So we have something here. Okay, so let me rewrite this form with a prettier symbol. We have a heart, multiply x, and equals to something else on the other side. I will call it a spade. And what you do? What do you do? Without using calculator, don't use a calculator, okay? What do? You divide both sides by heart. Heart is the parentheses. Spade is the whole thing, okay? So in the end, we have x equals to what? Numerator divided by the denominator. And this time the parentheses can be dropped. Okay, so I'm going to put this over here. Okay, optional. Okay. And of course, if you wish to know what, if you work with something like this in the calculator, well, and follow the rule of thumb. The entirety on the numerator in parentheses slash the entirety of the denominator in parentheses. This will guarantee you have no problem with the numerical value. Okay, this will guarantee with, even though I'm not asking for the numerical value, but just a side note. Okay, this is my sidekick. Okay, all right. So this is the answer. This is the answer. Okay, we're approaching the end of the class, and tomorrow we're going to continue on this. We're going to do number 20 as well. Okay, so by this time, of course, you need to go through the steps. You need to go through the steps and try different things. Okay, you may say, oh, I'm not taking logarithm, natural logarithm. I'm going to take common logarithm. That's okay too. And then you say, oh, I'm going to take log base 2. Why not? I'm going to take log base 3. No problem. Try all of that if you wish, if you will. Okay. Some of these trying, it might be reflected on your coming quizzes. But by doing this, you will be algebraically so much stronger. You will be. Okay. But anyway, without further ado, you should be able to do all of EXP1A by now. And tomorrow we're going to be here a little bit more. And we're going to move on. We're going to move on to EXP2. If you want more exercise, I have a collection of EXP1B and EXP1C. In these collections, I have collected the exercise. Some of those are from textbooks, and some of them are from my colleagues, and some of them are from my retired colleagues. And I put these together for you to practice. So if you want to practice a bit more and get even better algebraically, you know, just to kill time during pandemics, right? Kill time in pandemics. But anyway, without further ado, you guys are doing great, and I really appreciate those contributions. It makes me, you know, so looking forward to be with you guys. And I enjoy this class tremendously. I hope I have helped you to learn, to improve, and I'll see you guys tomorrow. Have a great day. I will be heading to the office hours, okay?
Thank you.
Thank you.